Video is on how to solve an electrical engineering type problem. The question is as stated. A 150 volt battery charger is used to charge a battery with an EMF of 70 volts and an internal resistance of 0.2 ohms. If charging current cannot exceed 20 amps, the minimum resistance in series with the charger must be. So I started drawing this circuit. This would be the charger, and it's charging toward the battery. This is going to be the battery, but it says right battery. It says that it has 0.2 ohms, so let's just put it as if it was separate. This would be the resistor. Now it says that the charging current cannot exceed 20 amps, so we have to put some kind of resistor in series with the charger. So we have to put another resistance up here. So what will that be? So let's just say what we know so far. The charger has 150 volts. Let's put it right over here. The battery has 70 volts because of the charger, and the minimum resistance was unknown, and the internal resistance was 0.2 ohms right there. Call that R in T. Alright. Put that like that. Okay. So now we will attempt to solve this problem. This problem is very simple. This is what you have to do. This charger has a voltage, but this is also voltage. They're both like a source of voltages. So we have to find the resistance from the given criteria, which is 20 amps, from these two voltage sources. So first, let's find the resistance from the charger. 150 divided by 20 amps volts. 150 volts divided by 20 amps is going to be 7.5 ohms. And then if you solve for the battery, it will be 70 volts divided by 20 amps is equal to 3.5 amps. 3.5 ohms, I mean. So how are we able to do this? Because it is just a simple circuit that's going in one, basically a loop, then current goes through just goes through without any kind of complexity. There isn't any special nodes going through or parallel resistances. It's just one loop in one circuit. That's why we're able to just divide the two voltage sources by 20 amps. So with that in mind, we have our two resistances from these two voltage sources. But here's the thing, we have this 0.2 ohm that goes with the battery. So we have to add this 0.2 with this resistance. So 3.5 plus 0.2 ohms is going to be 3.7 ohms. Now this is all under the criteria that the current must be 20 amps or less, just 20 amps. So the minimum resistance that you have to put must be 7.5 ohms minus 3.7 ohms. That will equal your R min. So when you subtract that, R min will equal to 3.8 ohms. So if you plug that in, 3.8 right here, you will get a current no larger than 20 amps. Of course, if you add more resistance, you'll get less current. due to Ohm's law. Alright, thanks for watching.